All right, well, welcome. In day 2, we are going to be looking at combining functions and their inverses. But before we do that, I want to just take a minute to review what we talked about yesterday. So I just want to remind you that when we're dealing with the inverse sine and the inverse tangent, we're focusing on quadrants 1 and 4. And so all our values, though, are going to be between negative pi over 2 and pi over 2. And when we're dealing with the inverse cosine, that's the one that's the easiest because that you're just dealing between 0 and pi. So you don't have to worry about changing the radians to be negative instead of, so they're all going to be positive for the inverse cosine. So we're going to use that in what we're doing today with combining trig functions and their inverses. And the way we're going to do these, we're going to set these up is we're going to go from the inside out. So we're going to start with whatever is in the inside. So in this case, we have the sine of 5 pi over 6. So we're going to start there. So the sine of 5 pi over 6, I'm hoping that you're going to get to a point where you don't have to visualize the unit circle, but I want you to see that now. But 5 pi over 6 would be right about here. So we want to figure out, again, what's that value? So this is sine. So that's your vertical distance. So the vertical distance there would be 1/2. So now we're going to take, so that means that this entire inside piece there represents 1/2. So now we're going to take the inverse sine of 1/2, meaning what radian value between negative pi over 2 and pi over 2 would have a value of positive 1/2. So that is going to be directly across from this one. That's going to be right here. And that would be at pi over 6 radians. So that would be your answer. So the final answer for the inverse sine of the sine of 5 pi over 6 would just be pi over 6. Let's try another one. So we're not going to do, so I know this says guided practice, but I'm not going to jump right in and have you try all 4 of these on your own. We're going to do the first 2. We're going to do A and B together. Because I want you to see, because sometimes people just think with these inverses that, oh, it's got to be the inverse sine of sine. They got to be the same trig function. No, it can be mixed together just like we have here in these examples, in some of these examples. So let's look at this first one. So the first one is sine of the inverse tangent of 1. So remember, for the inverse tangent, we're just like inverse sine, we're looking at quadrants 1 and 4. And it's 1 here in the middle, and so that's at pi over 4 radians. So this is pi over 4. So now we're going to take the sine of pi over 4 radians. So pi over 4 radians is at the same spot. So the sine value is going to be your vertical distance, which would be square root of 2 over 2. Let's look at another one. Let's look at the one next to it, 19b. So now just as a reminder from what we talked about at the end of our notes yesterday, arc cosine is just another way of saying inverse cosine. So we're doing the inverse cosine of the tangent of pi over 4. So let's start with tangent of pi over 4 radians. Well, we just did that one. Tangent pi over 4 would be here. So the tangent at that value would be 1. So now we're going to look at what's the inverse cosine of 1. So where is cosine 1? Well, that's right here, which is at, again, we're dealing with between 0 and pi, so we would call that 0 radians. So that would be your answer. So these, again, you're just using the unit circle, so I want you guys to work on these next 2 on your own. So do the inverse cosine of the cosine of 7 pi over 4, and then do the arc tangent, which remember that's the same as just the inverse tangent of the cosine of pi. So I want you guys to try those 2 on your own. So hit pause and then click on play when you're ready to check to see if you've done it correctly. All right, so let's see how you did. So for this one, cosine of 7 pi over 4, that, if you start, would be square root of 2 over 2. And then now we want to take the inverse cosine of square root of 2 over 2, and we get pi over 4 radians. So now inverse tangent, so the next one, inverse tangent of the cosine of pi. So again, you start on the inside, you work your way outside. And so the cosine of pi, hopefully you got that, it's -1. So the inverse tangent of -1, that's going to be down in quadrant 4. Now remember for that one, since it's down in quadrant 4, we don't label that as 7 pi over 4. Instead, going this direction, we would call that negative pi over 4 radians. So make sure you remember that for those inverse sine and inverse tangent functions. All right. Well, what if it's a value that's not on the unit circle? So in these problems, what we're going to do is we're going to be drawing a triangle but it's really important that we choose the correct quadrant. So how do you figure that out? Well, I'll get you there. Let's see how you do this first one. So the first one, we have the inverse cosecant of negative 13/5. Well, what's remember we have that phrase SOHCAHTOA, so sine is the opposite over the hypotenuse. Cosecant is reciprocal of the sine function, so this would be the hypotenuse over the opposite leg. And you got to remember too that for the inverse sine function, that's going to be in quadrants 1 or 4. So for this one, the inverse of the cosecant is going to have the same properties. This is going to be, since it's negative, it's going to be down in quadrant 4. And we know now that the hypotenuse, when we draw these triangles, the hypotenuse is always positive. And the fact that it's down here in quadrant 4 means our vertical distance is negative, so this would be negative 5. So just like we were doing the other day, what I'm going to do next is I'm going to use the Pythagorean theorem to find the missing side length here. So knowing a squared plus b squared, so b will be negative 5. When I square that, I get 25 equals c squared. 13 squared is 169. And so if I solve for a, I would just subtract 25 from both sides, so I get 144. And since we're dealing with a as your horizontal distance and it's to the right, we want a to be positive, so the square root of 144 would be a positive 12. So now that we have that, remember, by the way, theta is the angle closest to the origin. So now that we have all that, now we can find the desired outcome. The desired outcome is to figure out what's the cosine of that going to be. So we would say the cosine of theta would be the adjacent over the hypotenuse, 12/13. So that would be your final answer, 12/13 here. Let's do another one together. So again, with these that are not on the unit circle, the easiest way to start these is to draw a triangle. Again, you just need to figure out which quadrant that triangle is going to be in. So for this one, we're dealing with the inverse cosine. Remember, the inverse cosine is restricted to be between quadrants 1 and 2. So since the inverse cosine is dealing with a negative value, so it's going to be in quadrant 2. Remember, cosine is adjacent over the hypotenuse. That means the adjacent leg, since it's to the left, it's negative 5. The hypotenuse is always positive. So we're going to use Pythagorean theorem to figure out the other side length there. This time I'm going to call that b. It really doesn't matter. So a, when you square it, remember when you square a negative, it becomes a positive. So that'd be 25 plus b squared would be equal to 49. And so now when I subtract 25 from both sides, I would get 24. Take the square root. Now again, you need to think of this as it's going to be positive or is this going to be negative. It's going to be positive because our b value is above 0 there, so it's going to be a positive square root of 24. Now we do want to simplify these when we can. You could either use a factor tree, or I just like to look for perfect squares that divide evenly into 24, which would be 4. So I know this is the same as 4 times 6. Square root of 4 is 2, so this would simplify to be 2 root 6. Okay, so now that we have that side, now again, this is theta. So now we can find what we're looking for. We're trying to find the tangent in this case. Tangent, remember, is opposite over adjacent. So this would simply be 2 root 6 over negative 5. That can't reduce, so that would be your final answer. All right, so I want you guys to try these two completely on your own. So again, go ahead and pause the video and hit play when you're ready to check your answers. All right, let's see how you did. So for this first one, you should have gotten a final answer of negative 5/12. So if you didn't get that, let's see how you would approach it. So now remember, the cosecant is reciprocal of the sine function. So sine is opposite over the hypotenuse. So the cosecant would be the hypotenuse over the opposite leg. So and then since it's a negative, and since the inverse sine is restricted between quadrants 1 and 4, we know this is going to have the same restriction. So we know that it's going to be negative, so it's going to be down in quadrant 4. So you label your two sides that we know, the hypotenuse and the opposite leg, being negative 12 and 13. Use Pythagorean theorem to find the missing side length, and you find that missing side length to be 5. And once you do that, now we can just look at the answer. Remember, cotangent, which is reciprocal of the tangent function. So instead of opposite over the adjacent, it's adjacent over the opposite leg. And so then your final answer would be the 5 over negative 12. All right, finally, the last one there. So remember, the arc sine is the same as inverse sine of 3/10. So remember, that's positive, so that's going to be in quadrant 1. So you can set that up as the opposite over the hypotenuse. And when you use Pythagorean theorem here, you get the square root of negative 1. That can't simplify. And so then that we'll just leave it as square root of 91. So now we can use what we're looking for. We're looking for the cotangent. Cotangent, again, is the adjacent leg over the opposite leg. So in this case, the adjacent leg is square root of 91, and the opposite leg is 3. So this would be square root of 91 over 3 would be your final answer. All right. Well, I hope that made sense to you, and good luck now as you work on your assignment.